Recording in progress. So I am now recording this. So if there is anybody who doesn't want to be recorded or doesn't want their face to be seen, if you don't want to be recorded, I'm going to ask you to just drop off. If you don't want your face to be seen, turn off the camera. There's no one. Hey guys, I've got the face. If my face can be seen, your face can certainly be seen publicly. So don't worry about it. But if you don't like that, please go ahead and drop off. With that, I am going to welcome and thank Jason Bateham, and I'm hoping I'm pronouncing your name correctly, with Quick Innovative Solutions. And I'm hoping that you, Jason, you do plan on spending a minute or two being blatantly commercially advertising what you can do here to our group, because part of what I want to do, folks, is make sure that you are not only aware of the processes and the tools, but some of the people that you can turn to for different types of needs. So Jason came recommended to me through others in this industry. And so I'm going to pass it over to Jason. Thank you, Jason.
Sure. Thank you, Bob. I really appreciate the opportunity to present today. And I guess going into it, I just wanted to say that our hope is that you find the presentation insightful and maybe encouraging in your efforts to innovate and to begin bringing these innovations to life. I want to give a disclaimer, though, that just like, going to the grocery store, there's a lot of different paths that you can take. And a lot of what I'm presenting here today is kind of a mix between it's all factual in that we use this methodology and we stand behind it, but it's opinion in that this is what we think is a good route to take. So I think that listening to Bob talk about the having multiple speakers and having multiple perspectives, I think that that's a great thing. Listen to people that have experience and people that know, and then formulate your own decisions on how is the best way for you to proceed. So I don't have, the presentation is a little bit formal-ish, but there's going to be plenty of time, I think, for you to ask questions. And we're going to try to keep it not too salesy. I always hate those info seminars on LinkedIn that you chime into, and they're nothing but glorified sales pitches with a little bit of content. We're hoping that this is about 95% content and maybe 5% how to use QIS if we offer a service that you could benefit from. Okay, so let's see. Just let me know if chime in if we have any technical problems. I guess starting off, who we are. Quick Innovative Solutions is a really small company. We're a 3-person company, and what we do from day to day is we focus squarely on making products that help employees do their jobs better. Collectively, we have some decades of experience designing and producing new products, as well as refining and replicating existing products. So a lot of our industrial customers come to us and they have something that they've invented. They just want us to reverse engineer it, tweak it a little bit to make it manufacturable, and that's something that we do a lot of. So the products that we design and or refine have direct and positive impact on workplace safety, ergonomics, efficiency, and a lot of times on product or service quality. Not everybody that we work for, all of our customers are industrial, but not all of them make things. So they're not all in manufacturing. Some of them have service-based businesses. So our skill set and background include product design, 3D printing, a lot of machining, some 2D cutting. So that would be like a CNC, laser, Waterjet, something like router. We've done some design for assembly. We like to make things that go together pretty easily. We all strive for Lego functionality. We want it to just fit together. It doesn't always work that way. That's what we strive for. And then all of this is done on a foundation of lean manufacturing and continuous improvement. So we've got a pretty strong background in those two things. They were key at some of our previous employers. So we got more training than we wanted. So industries that we serve, you probably have already guessed some of them, but it's just a quick picture of depicting some of the industries that we serve, like automotive, transportation, aerospace, chemical, mechanical services, and then even service and logistics, like I said earlier. So without further ado, let's get started. So I think we can all agree that human beings are innovative. It's why we are where we are in the natural hierarchy. We're not necessarily the strongest or the fastest or most resilient animals on planet Earth, but we're kind of near the top of the pyramid, and that's because we're innovative and we work together. We've done that from the very beginning, and we're all, in some way responsible for some pretty amazing inventions. Go through just a couple. There's the wheel, and some of the structures that we've built. We've harnessed electricity. I think you guys here listening to Bob, you guys are squarely in this space. And then we've even got some inventions that probably aren't that big of a hit, but they're pretty innovative anyway, like some noodle cooling chopsticks. So, not all of them take off, but the point is that we always are trying to innovate. And a lot of times when we're innovating, we're making things. So, we kind of fast forward to, we can't chisel out a wheel or build a pyramid anymore, easily, but we fast forward to the modern age, and, we all have goals or I think everybody here has a goal of making things. And, when we think about making things, a lot of times I know my brain shifts to where we go to bring our innovations to life. And a lot of times I end up at a big box store when I'm working around the house. And now, whether you like Home Depot or another one, we can all agree that this place has a lot of tools and materials we're comfortable in using to make things. And you probably have some of these tools at home, but there's tools and materials that we can make things out of, but we're kind of limited there. And that's where I think we have to shift our perspectives a little bit and start thinking about what other tools are at our disposal. How do we get specialized parts, prototypes, or even small batches of products? And I think that the way to do that is through advanced manufacturing technologies. So shown here on this slide is just a few advanced manufacturing technologies in an ever-growing field. And in QIS, we always find ourselves using one or more of these technologies to make our products. And we're betting that you guys will need to use one or two of these as well. These advanced manufacturing technologies, they're not just the future, they're also the present. And there are a few things that these technologies and others like them have in common. This is not by any stretch an exhaustive list, but they all make precise parts, extremely precise parts in some cases, and they can do it repeatedly. They can make the same part the same way over and over again, whether you're making one or 1,000. And these technologies can also build these parts using high strength materials. These are industrial materials that don't compromise, like some of the machines and some of the materials we might have otherwise experienced. And they all require highly skilled technicians to operate and maintain. They all require substantial space and infrastructure to operate. They cost thousands, if not millions of dollars to purchase and use. And that's a little bit disheartening when we want to make things immediately, but take heart. One thing that I wanted to pass along today is that these technologies are all at your disposal. They're all ready for you to use to produce your prototypes and your products. And the best part is you don't need to own the technologies or be technical experts from the onset. But before we get too far along, let's spend just a few minutes looking at these, and I think you'll start to see some similarities. So first of all, plastic 3D printing. I bet these are the type of printers that Bob has at ATDC there at the lab, and may even have a resin printer, but we're not going to talk too much about that. But let's look at plastic 3D printing. We like it for a few reasons, and one is because it's affordable. These parts that you produce, they can cost, you know, as little as 20, 25 bucks, and then they can cost a whole lot if you go bigger and more advanced. And then the technologies in this space can produce parts made out of, you know, the big name polymers that we see used in industry. That's like nylon and high temperature plastics like the Ultims and some of the others. Polycarbonate is a really tough one. But these also can make really big parts. We know that they can make little parts, you know, parts small enough to fit on your fingertip, but they can also make parts that fill up a room. We've seen aircraft mock-ups and military equipment mock-ups made using really large format printers. So it's there. It's not just for pocket-sized items. CNC tube bending, I won't spend too much time on that. This is one when we put these slides together, we had just started trying it, but it's a pretty neat technology, and I wanted to cover it because it's a little bit different than cutting something or additive. But we found it to be affordable as well. A lot of times you can get bent tube shapes for well under 100 bucks, and most metals, or I'd say virtually anything that you can get a tube made out of that's metallic, you can bend. And then it's pretty much limited as far as the size goes. It's pretty much limited to the length that the tubes come from the foundries. Metal 3D printing. This is kind of like the golden fleece. Everybody's looking for this guy. Everybody wants to know about metal 3D printing. But you know, one thing that's a little bit daunting about metal 3D printing, it's really expensive. It's orders of magnitude more than machined metal parts. It's just that the powders cost a whole lot more, and the machines cost a lot. But it's important to know that, you know, sometimes you need metal 3D printing. There are some shapes you just can't machine. So this technology definitely has a place. And a lot of the materials that you can print with metal 3D printers are somewhat on the exotic side. You don't see a lot of just standard steel parts. You do see some exotics there. And then as far as part sizes go, we're not seeing a lot of giant parts printed with metal 3D printing technology yet. There's some hybrids out there that are more like, they're not powder based. They're kind of like robotic welders that, you know, just add bead upon bead until they get large parts. They're a little bit less limited in size, but it's really, really expensive. So waterjet and laser cutting, this is one of our favorites because it's pretty easy. Another one that's pretty cheap. You can oftentimes get parts made for, you know, in the $20, $25 range, and then it goes up depending on how big your parts are. And you can cut virtually any material that's flat. There's not much that you can't cut with these technologies. And lastly, the machines are big. So if you can buy a sheet that's 12 by 4 feet, you know, you can pretty much be guaranteed that there's a machine out there probably close to your locality that can do this. Then there's multi-axis CNC machining. So this is one that we kind of, you know, machining's been around for a long time, and sometimes we forget about it with advanced manufacturing, but it's a neat one, and it's always going to have its place, I think, for the foreseeable future. But you know, it's relatively expensive, or we found it to be relatively expensive. Maybe not as expensive as 3D printing metal, but it's pretty expensive. You can cut all kinds of things with a CNC machine, whether it's a mill or a lathe. It can be plastics, it can be metals, a variety of materials. And then you can cut really large parts. I think we've probably seen those big gantry machines that can cut parts, you know, 40, 50, 60 feet long. And then we've seen small tabletop machines you can cut small parts with. Now, I guess closing it out with these that we just covered briefly, you may know exactly which process or material you need to employ to make your product, but you may not. You may even be wondering how to get started. But the good news is that there are experts in the field ready to help you right now. That's their job. You don't even need to know anything or everything. You don't need to know that much about these technologies. But one thing that you do need to know and recognize from the onset is that this is the digital age of manufacturing. I can't emphasize that enough. Everything is digital now. A drawing or a set of drawings may be enough for some of the vendors that you want to use to make your parts, but even those vendors are going to have to take your drawings and digitize them. So, you know, that's what I'm driving at. If you don't have a digital version of your design, you've got to get there somehow. So I'm showing this slide. This is a custom machine that we built. It's very specific for lifting some spray dryer nozzles in a chemical manufacturing plant. And one thing that I wanted to go over is that in this design, you can see this is a screenshot from our CAD software. In this design, there's lots of different parts. There's 3D printed parts, there are machined parts, there are Waterjet cut parts, and there's tons of off-the-shelf components like hardware, extrusion, aluminum extrusions cut to length, casters, all kinds of stuff. And by modeling this product, though, one thing we were able to see is how everything fit together. We're able to see that without having to actually build something and handle it. So it's limited, but it's a perspective that we wouldn't have with just, you know, pen and paper, we think. We're also able to break down this total assembly into individual and singular models. So we can pick one single part out of this assembly. We can right click on it and say isolate, and it just shows just that part. And we can export that part as a file to send to a vendor, or we can export a series of files. We can do a lot of different things, but this is just kind of like our master product here with a lot of different parts that feed it. So I guess you can kind of see how it all goes together. We're not pushing one particular technology or one particular approach. We just want to encourage you that with, you know, when you digitize your product, you can put everything in there and see how it goes together. And sometimes you can prevent some problems that you might otherwise have ahead of time without a whole lot of cost involved. I guess so, recapping, all the manufacturing technologies we looked at in the previous slides make parts by referencing digital models. That's their blueprint. And a model of your product, that's going to serve as the Rosetta Stone that you'll use to convey your idea to companies that are squarely based inside of these manufacturing technologies. You may have a product that's pretty advanced, and maybe a guy that's machining parts doesn't have any idea what that's going to do or what it's going to be. But once you show him that digital model, he's going to know what his role is in helping you to get that part. And lastly, I think with the digital model, there's little room for manufacturers to misunderstand what it is that you need. It's a lot better. It's a lot better than a whole bunch of verbiage, a paper napkin or something like that. So I guess going into, you know, how do I get a model? And the destination to a digital model is like any other destination. You know, I talked about it at the beginning. There are a few paths you could take, but for the sake of simplicity, we'll just cover two today. And the first way you can get a digital model is to do it yourself. You could begin learning modeling software. You don't have to be an engineer or a designer necessarily, but you could do it yourself. If you don't have modeling and manufacturing experience, it may be an arduous journey. It could be tough. Could be a little more time consuming than you're hoping for, but it might not be out of the realm of possibility. But if you do have the designer's eye and a rudimentary understanding of these manufacturing processes, that's something that, you know, we don't want to turn you off from doing that. And we'll list a few solid modeling suites that we are comfortable recommending at the end of this presentation. And you can refer to them later and take a look at them at your leisure on your own. A lot of them are going to have, free trial periods. Some of them are even free to use with certain conditions. And then the second way you can get a model is to partner with a company who can do the modeling for you. And if your short-term goal is to get a prototype in hand, this is something that we here at Quick Innovative Solutions.
Let me ask everybody to go on mute. I'd prefer not to mute everybody from here, so I'll just ask everybody to put themselves on mute. Thank you. Sorry, Jason, go ahead.
No sweat, no sweat. Yeah, so if you're looking to get a prototype pretty quickly, that's something that we can help with. We work on an hourly basis and we don't have contractual requirements, so it's pretty easy to work with us. I think that's what our goal is. And we try to make things quick and simple for people. We like that. If you're looking at a really complex product, or you're looking to get a product digitized that's going to be mass manufactured, that is like greater than 1,000 units, something's going to be plastic injection molded or mass machined or something like that, then we may not be the right fit for you. You may want to go with a firm that specializes in that type of thing, and they are out there. I would search, if it were me and I was looking to mass manufacture something, I think I would search for a product development firm, and I would find one. I know there's one or two in Atlanta for sure, but that might be a better fit for mass manufacturing. And the reason for that is they're just more familiar. There are professionals out there that are just more familiar with specifications for injection molding and for high volume machining than we are. We're pretty good at guerrilla warfare or guerrilla design. Okay, and some softwares that we like, here's just a few. SketchUp has been around. I think Google may have bought them. They've been around for a little while, and their reputation precedes them. We don't have any experience using them, but it's reported to be, in a variety of reputable sources, it's reported to be a good, solid software to start with. And I know that they have a free light version that you can use immediately. And I know they have a pro version that's just a few $100s. And I don't know if that's a license for a year or if that's, one and done. I just don't know. The software that we use is Fusion 360. We like that for a variety of reasons. One is it's extremely powerful for the type of designing that we do. We're not designing full-on aircraft with all the parts contained and, fuel systems, electrical systems, and all that. So we don't need a bulldozer of a software. This is great for mechanical parts, though. And I think it's probably somewhere around the $400 to $600 a year range for a seat. But they also have a free version that that's fully functional. You just swear in a test that you're not going to be making a profit using their software. And I think that would fit a lot of what you guys are doing, the stage at where you're at right now with your products that you're developing. So yeah, don't be afraid to try that out. And it's also very, very common or commonly used across the design space. So there's tons of content to show you how to use that software. And then, the last software we'll touch on is SolidWorks. It's kind of a gold standard for mechanical designers. It's also $3,000 to $4,000 a year for a seat. So it's relatively expensive. But it's powerful, no doubt. And a lot of these will run, all of them will run on PCs. And I think Fusion may be the only one that'll run inside of a Mac natively. But I think that's kind of wrapping up what I wanted to cover. I think driving home, I realized that what I'm really pushing towards is I don't know much about what you guys are doing. Bob told me just a little bit, but I don't know where you're at with your products or where you're hoping to be in the near term or long term. But I hope that this gives you an idea that eventually when you get to the point where, whether you're there now or whether it's going to be some time to come, I think the key takeaway is that going digital is the way. That's the bridge to get you to a physical part in this day and age. You don't need draftsman skills anymore, but you do need to have something that you can use to communicate with people that are going to be manufacturing these parts. And we think of that as a digital model. So I guess I'll pause there and ask if you have any questions. It's kind of a dump truck full of opinions and thoughts. Let me know how I can help.
So I'm going to start this off with first, Jason, thank you. That was fantastic. That's exactly what we were looking for here. My first question, give me an idea of the general batch sizes that you work with at Quick Innovative Solutions. So if I'm doing, 1,000, that sounds probably like more than what you do. So give us an idea on that.
Sure. And we have, I think anytime, so there's small run, there's a place where I wish I should have drawn a curve, but I can describe this one. If you look at a chart of part cost versus volume, 3D printing is almost a straight line. And a lot of 2D cutting is not too far off from there too. It's kind of a straight line. You start off with a part that costs $25. You make one of them's $25. You make 1,000, they're $23. You're like, wow, that's not much of a cut. Well, it takes the machine just as long to make one. If you make 1,000, it's just machine time times 1,000, and you don't get a break on the material or anything like that. So I guess 3D printing and 2D cutting, to some degree machining, they all make sense on batch sizes up to maybe, and it's part dependent, but maybe 100 parts, sometimes 500 parts. Once you get up to 1,000 parts, particularly if you think of like a plastic housing for an electrical component, if you need 1,000 of those things, you're probably going to want to start to explore some kind of a casting process or a injection molding process. And there are some 3D printing processes which are kind of blurring the lines a little bit. You guys may have heard of Hewlett-Packard's Multijet fusion technology, but that's a technology that gives you a plastic injection molding quality part really quickly, but it's still, I would say it's still closer to the 3D printing spectrum. I guess at batch sizes, what we've done some assemblies in quantities of 400 and 500, and then we've done 2 or 3 copies of various prototypes.
Okay. And let me open it up to folks. I'll just ask you to just unmute and go ahead with whatever your question is.
I have a question regarding the level of digitization that you would expect a company to give you. Like you said, you don't necessarily have to have draftsman skills. I have some draftsman skills, okay? But can you explain that a little bit more? Because I know you showed the picture up there with that device that was made. So what would be expectations of some of the people I know who are on here who may not, have that level of software or experience or anything like that?
Okay. Well, one thing that's pretty neat about this technology, we at an employer that I worked for some years ago, I managed a 3D printing lab, and we would have engineers send us models to be printed. And one thing that we recognized that we had to pass along to them is that you can slap all of the geometric dimensioning and tolerancing that you want onto a 3D model, but the printer doesn't care. The printer is going to make that part as close to nominal as it can. And there are limitations. You know, some of the printers are more accurate than others. With 2D cutting, it's not entirely different. If you send you can send your model to a 2D cut house, and you can slap datums on the model, and you can tell them, you know, this is a critical surface, and, you know, and you can dimension it every which way you want. You know, that used to be the important thing. You wanted to, you established your 3 datums, and then you made your dimensions off of that. That matters a lot in the machining world. With these machines that we like to use, you know, they're within 10 or 15 thousandths of nominal most of the time on virtually all of the dimensions. And that's good enough for the types of products that we make. That may not be good enough for, you know, if you're making a plastic injection mold or something like that. And that's where I don't have a lot of experience in that area. You know, this day and age, it's kind of, you know, we're kind of, we've taken the engineering out of engineering in a lot of ways, and that's good. It has positives and it has negatives too. But yeah, if you can make a solid, if you can design something in CAD, there's a good probability that somebody can make it for you to match what your design is.
It's probably, Jason, tell me if you disagree, but it's probably safe to say that the more precise your design is, the more in depth, the more accurate the output, whatever it is going to be, wouldn't you think?
I think yeah, that definitely helps. Definitely helps. You want to get it really close. That's one area where CAD can help you. It can get you really close, and you can look for clashes and for places where you might not get a good fit. Yeah, so it's that old adage, garbage in, garbage out. It's the inverse too. If you put some time into it, you're probably going to get a good product. These technologies, like I said, the ones that I covered are extremely advanced. They're extremely precise. They don't make a lot of mistakes as far as manufacturing goes. They're not perfect. There are some times that, you know, if you design something that has to have a critical feature or critical dimension, you may have to, it may be a 2-process or more operation. You may have to blow it out with a laser cutter, and then you may have to come back and post machine an edge. But, you know, these are things that are, you know, part by part.
Okay.
They're part by part. Yeah, we don't see a lot of need for, you know, there a lot of times we want this uber precision, but in the type of work that we do, we just don't see a lot of need for it.
Interesting. Okay. And then
Yeah.
Mac Lund in the chat asked, what are some of the file formats that are preferred or not preferred for 3D printing, 2D cutting, and machining?
Okay.
So 3 different processes there. I can read those off to you again if you want.
Sure. So, you know, one thing that's really good for that's good about these softwares is they can make the files that you need for any of those manufacturing processes. For 3D printing, the gold standard, or it's not really the gold standard. The standard now is still a .stl file. That's like a standard triangulation language or something to that effect, or stereolithography, some people say. But that's kind of it's a dumb solid. So what the software does, it takes your 3D file, which is essentially a lot of math with a visual representation or a graphic representation. It takes that math and it turns it into a bunch of surfaces that are made by splicing triangles together. And you can read on that on your own leisure, but so there's a little bit of dumbing down to your product that's done at that stage for the 3D printer to understand. So STL is the takeaway. Some of the printers now are doing a .3 MF file, which is a little bit smarter. solid, but it's still a bit of a dumb solid, but it can hold stuff like color and things like that, I believe. We don't have a lot of experience with that one. As far as 2D cutting goes, the standard is a DXF file. It's been for a long time. I think that's the same type of file that the old plotters used to use for making blueprints. And then there's, for machining, you know, that really varies. What a machinist does a lot of times is he takes your file and he turns it into he pulls it into a CAM software, which is not computer-aided drafting, it's computer-aided manufacturing or machining. So, you know, if you have SolidWorks and he's using a SolidWorks CAM suite, then he can just pull the file over directly from or he can pull your SolidWorks file over. But one place you can't go wrong is you can't go wrong just by sending help me out, Fatty, what's a step file? Yeah, stp.stp file or a .iges file can be used. But again, all of these softwares that you're going to use, whether it's Fusion, SolidWorks, and probably SketchUp, again, I don't have experience directly with that, but I'd be willing to bet all of those, including SketchUp, will export the files that you would want or that your manufacturing partner would need.
Okay.
Best thing to do is to ask that. That's kind of I gave you a little bit of a generic or a general answer. Best thing to do is to ask your manufacturing partner what file type they prefer.
Okay. We're starting to get in a couple of more questions here. So I see a couple of hands up. I'm going to go and read a couple of the chats and then go to the hands that are up, because I think that's the order they came in. What are expectations regarding pricing? What if you have a plastic part with an electrical component? Parentheses, any suggestions when someone has more than one technology, mechanical and electrical?
So my partner here is electromechanical engineer, but believe it or not, we haven't done a lot of electrical work. So I don't have much experience with that. I do know, you know, as far as you may end up having to split the parts up and look at it as a two-piece assembly or a two-component assembly. Take split your electrical part from your plastic part and then figure out how they go together. But not being an electrical, I'm a mechanical engineer by education, and I had an intro to circuits or something to that effect, but man, I don't remember. I can work on the circuitry in my house, but that's about it. So I'm sorry if that doesn't help.
I'm going to go to George, then Marshall, then Randy. So George?
Good morning. Thanks, Jason. My name is George Holmes from Higher Henry. We're developing robotic lawnmowers, primarily to, maintain large green spaces. A couple questions for you. Can you talk a little bit about like Xometry and Fiverr, some of the freelance services that are out there, and easy ways that people maybe can go to Xometry and submit files to get it printed like they're ordering something off of Amazon?
Yeah, that's a good one. And I didn't bring those up because there are a bunch that are out there. But let me give you a little bit of my take on some of these. I'm not paid by any of them. Believe me, they get my money. Xometry is a good one because of the variety of services that they offer. One thing that I can tell you about Xometry, though, is Xometry is really it's a management business or a brokerage. So what they're going to do is they're going to take your design and they're going to put it on a board somehow behind the scenes, and then some manufacturer is going to claim that job, and then they're going to be required under their contractual agreement with Xometry to make that part to a certain accuracy. And then they're going to ship that part to you, or those parts to you. There are pros and cons with that approach, but we've had nothing but positive experiences with Xometry. So if you have a model and you send it to Xometry, I'd say you're in good hands. One that we've talked to recently is Fast Radius. That's another one. They're a little bit different than Xometry in that they are not a service brokerage company. They actually own the technologies that they use. They have dozens, if not hundreds of machines. They have probably dozens of different types of manufacturing processes. And what that's going to get you, they also have project engineers, which Xometry does too, but they have project engineers on staff who are going to be able to run interference between your design and the manufacturing side of the house, and solve any problems that might pop up in between. We've had parts that we've printed that had we had somebody looking out for our interests on the print side, they probably would have called us and said, hey, your walls are going to be a little bit too thin here, or this part's not going to be as strong as it needs to be. Most of them aren't asking you, hey, what does this do? Or, what kind of loads is this thing going to be subjected to? They're just turning your parts out. It's good to have a partner, which we haven't worked with them yet, but we're looking to work with them. Fast Radius is probably them. But it's good to have a partner who's willing to look at that and raise a hand or throw a flag when they see that you might do better to design something a little bit differently. Believe me, you want that criticism or that feedback up front rather than after you get a few of these things, and definitely after you get a few of them out in the field.
Yeah. So just a quick follow-up on that, Jason. Are you guys outsourcing all of your manufacturing, or do you have CNCs and Waterjet in-house?
Yeah, no, we're a little bit of a hybrid right now. So we're a young company, George. We outsource anything that requires using a machine that costs a lot of money. We outsource. We have a couple of 3D printers. We have one that's we have an Ultimaker that we use for just prototyping. We don't sell customers parts made with an Ultimaker. We have a Markforged Mark II that we have sold parts from, and that'd be a carbon fiber reinforced nylon. So that's an industrial type material. And we partner with a local vendor here in Savannah that does our 2D cutting. So anything that we need cut out of 6061 T6 or stainless steel, anything like that, we get it cut outside. Now, to date, all of the assembly we've done, we do a lot of, I would say, rookie machining. Like we do drilling and tapping, and we can do a whole lot of assembly in-house, and we generally do. But we're trying not to get out of the or trying not to get into the manufacturing space so much, because we want to be in the solutions business, not the running machines business, if that makes sense. You're going to be real careful by making a commitment to buy technology. Before long, the nature of your business shifts from what it is you were hoping to do to man, I got to feed this machine or I'm going to starve this month. You just want to be, that's where we're at.
All right, let me go to Marshall. You had a question.
Thanks, Marshall Shoemaker. So thank you so much. I'm in the software product development world, and so I'm not sure about the analogies, but it can be very expensive to build a mean viable product or a working prototype. Yes. And it takes a lot of time too, but I need money, I need investors. So I'm wondering what your experience is with inventors and entrepreneurs coming to you and say making a mock-up versus a working prototype and getting money.
We haven't done that yet. We haven't made a mock-up yet. We've done some prototypes, and we've done everything that we've made starts with prototypes. But mock-ups
I will,
are possible. Yeah.
Let me jump in on that too, Marshall. That's a very good question to bring up for tomorrow's session also. So I think
Okay.
I think you're signed up for that, because that'll Shane will bridge a lot of what you're hearing between them. So that's a very good question for that.
Yeah. So one area, Marshall, speaking of that from a mechanical perspective, one thing that you could do is, we have made parts out of you know, Ultimaker plastic, which is just a PLA plastic. We've made parts that otherwise are going to be made out of steel or maybe, you know, some heat treated aluminum. And it's cheaper. You know, you can feel the part, you can hold it in your hand, you can see how big it is, you can see how easy it's going to be to put together and things like that. So I guess that would fall in the territory of mock-ups. You know, we had some experience with mock-ups at an aerospace company. You know, it's cheaper to make a mock-up than it is to make an aircraft and cut it into a section, you know. So yeah, definitely, if you're looking to put in a dumb part or maybe get a mock-up that's shaped and sized like your final part's going to be, but you're not ready to invest just yet, or maybe you have some of your product designed but you don't have all of it designed, then that may be a good place for a cheap mock-up. So yeah, there's definitely room for saving money. And I appreciate the software analogy, because you have to build the software before the customer can see if it works, right? And it's very, very expensive.
Yeah.
All right,
Thank you.
Randy, how about you? And then I'll go to Victoria. You're on mute, Randy.
Okay. All right. Thank you. In terms of, Jason, in terms of a stack of cards, if you had a stack of cards, for example, would you miniaturize that to go in a device that we had?
Let me see. So if we had a stack of cards, like what kind of cards?
Any kind of electronics cards.
Yeah.
Would you miniaturize those? Do you have the engineering services?
Are you
to-
talking like PCB boards or that kind of thing?
Yeah, yeah.
Okay.
No, that definitely would not be us. Yeah.
Okay,
I'm sorry.
okay, that's fine.
Victoria?
Well, good morning. I hope everybody is well. Please forgive me. I was a little late joining this morning. To Jason, can you share again exactly what your organization does? I am interested in having a prototype made. This is a tool, a lever of sorts. We've had a 3D print version. We have a handmade version. Our scale seems to be pretty good. We are just trying to find a material that's going to be firm enough or hard enough to withstand, what it's being used for. I heard you mention aluminum or steel, and we're considering that as the next type of material we might use. And I'm wondering if you can do any prototypes out of that type of material.
So yeah, so I guess going back to what it is that we do, Victoria, we're a small company that helps industrial customers. So we help companies get products that will improve the lives of their employees. And a lot of times they take the shape of tools or maybe their machine add-ons, things like that, or maybe their machines, standalone machines of some sort. But we do that with 3D printing, with machined parts, with two-dimensional cut parts, and then product design. We design for ease of assembly. A lot of times we find ourselves integrating off-the-shelf components with custom components. One thing I saw at another job was, customers that would come to our lab and they would see that we had a 36 by 24 inch by 36 inch printer. They would say, "Oh man, I can print a giant part." Well, just because you can doesn't mean that you should. Maybe you should cut a long section out of metal and then use printing or some kind of advanced manufacturing process for the contoured components that can fit on the ends. But back to what you're asking for, we've done a lot of that. A lot of our industrial customers come to us with homegrown solutions or solutions that they've made in-house. And what we can do is we can take those solutions, we can digitize them, if they're not digitized, if you've printed something, then you already have a digitized version. But we can take that and help you get something that's stronger, or we can at least advise you on what's out there. I think it was George who asked too. There are other entities that can do that too. Fast Radius, they can take a look at your model. There's also Stratasys Direct is another one that we've used in the past that we like. You know, they could take a look at your model, and I think that these companies that I'm mentioning, they are not interested in your intellectual property by any stretch. They just want to make parts for you. So I think it's something that you could talk to them about if you want. You could also talk to us about it. That's something that we could help with. But
Yeah, I would love to talk to you. One of the first things that you said that interests me is that you work with companies that are trying to develop potentially things that will improve the employee's life. And that's exactly what this tool is.
Okay.
And it's something to help people that operate heavy equipment, buses and things that have manual handbrakes. And so it just matches exactly what you said. So I will be reaching out. I have your information here, and thank you. And again, I apologize if you had to repeat anything. Thank you so much.
No, it's
All
my
right,
pleasure.
so I'm going to go to, let's see, I think we have time for this one more question. I've got something in the chat window from Laura. Do you work with suppliers, vendors, brokers to find specific components for customers such as chipsets?
We have not for chipsets. We've done some of that on a limited basis for mechanical components, but not for chips, no.
Okay. All right, so I am going to bring this to an end. First, Jason, thank you. That was fantastic. That was better than I had hoped for, which I had pretty high hopes. So that was terrific. I want to thank everybody for being here. My email address is in the chat window. So if you have additional questions, like Victoria, go straight to Jason. If you have more generalized questions, come to me and I'll distribute that out to the various folks. A reminder, we have another session tomorrow, 11 o'clock with Shane Matthews. If you are not on that and you want to be, send me an email for that. I will be posting this talk on the ATDC YouTube site probably later today, but again, I am doing a prototype of how to do a prototype march. So if I mess up a little bit, laugh at me, don't get mad at me. But that should be out later. I will circulate that URL to everybody who was on today and everybody who had signed up. And with that, thank you, everybody who was on, and talk to you soon. Do lots of prototyping. Prototyping is how you get your business to where it needs to be. So talk to everybody soon. Thank you.
Thank you.
Thank you.
Thanks.
Thank you.
Really appreciate it.
Thank you, Bob.